Assalamualaikum. Today we'll be discuss about titration and its importance in food industry. We will start with introduction. Do you ever heard about titration? Titration is the slow addition of one solution of a known concentration called a titrant to a known volume of another solution of unknown concentration until the reaction reach neutralization, which is often indicated by a color change. Purpose of titration to determine the concentration of an unknown solution. What is titration in food industry for? To analyze the precise amount of food additive and nutrients that need to be added to process food products, or to analyze the purity of substance for quality control purpose.
I will tell you about the term in titration. Several phrases are frequently used to characterize the titration process and its result. The following are some important terms. The first one is titration, the process of determining the concentration of a substance in solution by adding a solution of known concentration until the reaction reaches stoichiometric equivalent. The second one is analyte, the substance whose concentration is to be determined. It reacts with the titrant in a chemical reaction. And the third one is standard solution, a solution of accurately known concentration used in titration to determine the concentration of another substance. And the fourth one is equivalence point, the point in a titration at which the added titrant is chemically equivalent to the analyte. It is often marked by a sharp change in pH or another measurable property. And the last one is endpoint, the point in a titration at which an indicator change color or a detection method shows a significant change indicating that the equivalent point has been reached.
So next is our methodology using an experiment, which is the fruit juice sample. Since in the fruit juice they contain some citric acid, which is the common acid found citrus fruits, and the concentration in the fruit juice is quite interesting in the food industry. So the purpose of our methodology is to determine the citric acid content in the fruit juice sample. Then before we proceed to the procedure, we preparing the apparatus and chemical itself. So for apparatus, we got the burette, pipette, retort stand, conical flask, funnel and white tile. For the chemicals, we got phenolphthalein indicator, 0.1 mole sodium hydroxide, distilled water and fruit juice. We have to standardize the sodium hydroxide itself first, which will titrate the sodium hydroxide solution with a known quantity of oxalic acid or potassium hydrogen phthaleate. Afterward, we prepare the sample preparation, which dilute the fruit juice sample to the proper concentration and combine thoroughly. So after we have standardized the sodium hydroxide solution and we got the sample preparation, then we can proceed to the titration procedure. So first, we have to pipette a volume 10 ml of the dilute fruit juice into conical flask and add a few drops of the selected indicator phenolphthalein to the dilute fruit juice. Then fill the burette with sodium hydroxide solution. Pipette 10 ml of the dilute fruit juice into a 250 ml conical flask. Added 2 to 3 drops of phenolphthalein as an indicator. The sample in the conical flask was titrated with sodium hydroxide from the burette slowly while shaking the flask until the indicator color change. The color change phenolphthalein, the solution changes color from colorless to a faint pink, and the reading at the end point of the titration were recorded. Record the volume of sodium hydroxide solution used to titrate the dilute fruit juice sample at the end point. Lastly, repeat 2 to 3 times and record all the readings in the table.
So, next I want to explain about the example of the result for this titration in food industry. In this presentation, I'm going to present the result of determination of vitamin C in oranges. In this section, I'm going to be pointing to two equations, which is the first one is the amount of ascorbic acid in orange juice and another one is the iodine solution standardization. From this table, we found that the average amount of ascorbic acid contained in 1 ml iodine was 0.19 mg. This data will be used to determine the value of ascorbic acid contained in the orange juice. Next, we are now moved to the table 2 that contains the value of saturation in order to determine the value of ascorbic acid contained in orange juice. From this table, we use 10 ml of orange juice in each titration. Lastly, the result obtained, the average amount of ascorbic acid that contained in the 100 ml orange juice was 25.175 mg per ml.
End of the video, we can conclude that titration can be used to determine an unknown concentration, can help to calculate the pH value of the solution, and we can know that the solution is either acid or base. Other than that, help in food industry to determine amount of acid content in food. And titration has two parts, which is back titration and direct titration.